Yeah, am I audible?
Yes, sir.
Yes, sir.
Go to the next module, second module. What is the heading? Block diagram reduction techniques. Block diagram reduction techniques and signal flow graph and signal flow graph. So what are some of the techniques which you are using for a problems? So these are some of the block diagrams we need to reduce in this chapter, in this module. We have block diagram reduction techniques, and also we are going to study about the signal flow graphs. So this is once again to find out the transfer function by output to input. So in the block diagram reduction techniques, we have multiple blocks that are interconnected. So to find out the transfer function, that is output by input, we need to make it into a single block with the help of these techniques. Here, these are some of the techniques. So here, look at here, we have R of S as an input and Y of S as an output, and we have two blocks, G1 and G2, that we need to make it into single block. So to make it into a single block, if we have a two blocks are in series, we need to make it as a product. So two blocks are in series, so there is G1 into G2. So two blocks into a single block. So there is what R of S is Y of S divided by R of S. In the same way, we have two blocks are in parallel. Yeah. In the same way, two blocks are in parallel. So the reduction of those two blocks into a single block. So parallel connections, we need to make it as addition G1 plus or minus G2. You have a plus or minus symbol here. So if it is plus, we need to perform addition. If it is minus, then we need to perform subtraction operation. And in the same way, here we have an input as R and we have a single block as G1. And here we have an intermediate point that we call it as a takeoff point. So that intermediate point, we call it as a takeoff point. So in some of the cases that we need to move, so just look at the third and fourth one. So here we have a takeoff point after the block. So for some of the problems, we need to move that into before that particular block so that the problems look simple. So to make it as simpler because of the next, if we have a multiple blocks are interconnected. So for example, so here we have a two blocks are in series. So normally we have a G1, G2. Normally if it is in series, we can able to write that as G1 into G2. But in between, if we have a one more takeoff point, so then it's not possible to write down that as G1 into G2. So for those kind of cases, we need to move this takeoff point before the block or else after the block. So then we can able to make that as G1 into G2. So for these kind of cases, here we have two such cases. So we can able to either move before the block or else after the block. So for these kind of cases, just look at the proper observation. Here we have an input as R. So at this particular point, we have a R into G1. So now that indicates we have a output as R into G1. So Y is equal to R into G1. And this for intermediate point, the intermediate output we have labeled as B. So B is equal to R into G1. So here also we have R into G1 and here also we have R into G1. So now once we move the takeoff point from right to left, then, so just look at that observation here. So here just we have a takeoff point, that is B is equal to, here we have an input only as R. So now here we have an output as Y is equal to R into G1. So now look at this, we have only R interconnected to variable R is interconnected to B, so that indicates B is equal to R. But here initially b is equal to r into g1. So that is the variable present in this particular block. But here we have a b is equal to r, but we need to make that as r into g1. So here at this point we need to add the block at variable name should be g1. So now here we have a r and here we have a g1, so that b is equal to r into g1. So that concludes, if we move the takeoff point from right to left, then whatever the variable that is present in this particular block, that we need to make a product here, that we need to make a add here. So now b is equal to r into g1. So this, that is to retain the same thing here. Here the intermediate output is b is equal to r into g1. So now the intermediate output initially it is b is equal to r. To make it as b is equal to r into g1, I'm going to add that particular block or this takeoff point. In the same way, here we have a takeoff point. So look at here, we have a r b is equal to r. So now in this case we need to move the takeoff point from left to right. So once we move the takeoff point from left to right, so here we have a g1 and here we have a r, and now we are moving the takeoff point from right to left. So now from left to right, once we move the takeoff point, so here we have variable as given, that is going to make a product here. By default, that is going to make a product here. So now b is equal to r into g1. But initially, in the previous case, we have only b is equal to r, but now it is b is equal to r into g1. To make it as b is equal to r, so what is the block we need to add here? We need only b is equal to r. We don't want g1 here. So we need to cancel that g1. To cancel that g1, we need to add that block variable as 1 over g1. So whenever it is 1 over g1, so now this particular block output as b is equal to r. So in that manner, we can able to do the proper operation. So output is once again y is equal to r into g1 only, but we are taking care of only the takeoff point observation. So initially b is equal to r. We need to make that shift the takeoff point from left to right. Then we need to perform the division operation. Whatever the variable is present here, that we need to perform the division operation. This particular block labeled as 1 over g1. 1 over g1. So b is equal to r into g1 divided by g1, that is equal to r only. So that is equal to b is equal to r. So now I'm concluding these two. Once we move the takeoff point from right to left, then we need to add the variables that is present in this particular block. So here we need to add the particular block. Once we move the takeoff point from left to right, then we need to perform the division operation of whatever the variable it is present in the particular block. So that is 1 over g1 here. In the same way, so this one we call it as a summation point. So the previous cases are with respect to takeoff points. Now here it is summation points. So in some of the problems, we need to move the summation point itself as a either right to left. So here instead of takeoff point, if we have a summation point, then once again to make it as series, we need to shift this takeoff point either to the left or to the right. So for those kind of cases, so just look at here, y is equal to rg plus b. So here at this intermediate point, we have a rg, and here we have variable as b, so that y is equal to rg plus b. So now once we shift the takeoff point, once we shift the summation point to the left, so now I'm going to shift the summation point to the left. So the output we need to maintain is y is equal to rg plus b. So here we have a r. And now here we have a temporary variable as b. So at this particular position, if it is going to perform summation operation, so what's the output here? So here we have a r and here we have a variable as b. Here it's a summation point, so that concludes r plus b. And r plus b is going to make a product here as with g. So r plus b is going to make a multiplication with G so that is equal to Y plus BG. So we need to maintain the same output as Y is equal to RG plus B. But here we have output as RG plus BG. So this G we need to cancel. To make a cancel of that particular G, here we need to add a one more block as 1 over G. So now it is B divided by G, so that R plus B divided by G. So R plus B divided by G, so that it becomes G to G get cancellation, so that we can get RG plus B. So now, if we shift the point from we shift the function point from right to left, then we need to perform the division operation of that particular variable. So this is how we can perform the division operation. In the same way, for last one, for sixth one, so the right down here. So now, at this particular position, so we have output as R plus B here. R plus B, making a product here. So R plus B into G, so there is RG plus BG. So now, if you are going to shift the summation point to the right, so here we have a block as G point to the right. So here we have a R, and here we have a G. So at this particular position, we have a RG, and here we have summation. So Y is equal to RG plus B. But here the output required as RG plus BG. So we got the output as Rg plus B. To make it as Rg plus Bg, we need to add this particular block as G, so that here we have output as Bg, so Rg plus Bg. So once we shift the take our summation point from left to right, we need to perform the subtract multiplication operation. That is to add a variable here. If we are going to shift the summation point from right to left, then we need to perform the division operation as 1 over G. So these are the 6 cases we can able to observe to solve the block diagram. So write down. ಬರ್ಕೊಂಡಿದ್ದ
Yes, sir.
Write on the next one. So this is to find the expression for a feedback path. So initially we have an input as R of S, and we have a two blocks here, G of S as well as H of S. H of S is acting as a feedback with a negative symbol, so it is acting as a negative feedback path. So here we have some temporary variable as u of s also. So the final output initially I'm going to write down the final output y of s is equal to, so these two are in a product format. Y of u of s as a signal to the g of s, so that u of s is going to make a product with g of s. Afterwards, this intermediate signal u of s can be written as, just look at the observation at the summation point. Here we have input as r of s, and here we have input as b of s. So u of s can be written as r of s minus b of s. Afterwards, make a product of these two, that is g of s into r of s minus b of s into g of s. And then g of s into r of s, that's the input. And for this b of s, so for this b of s, so look at here, this is the intermediate point as b of s. So here we have an intermediate output, here we have a final output as y of s. So y of s is going to make a product with h of s, that is equal to b of s. So b of s is equal to y of s into h of s. And here also we have a y of s. So just shift that to the LHS part. So y of s plus y of s g of s into h of s is equal to g of s divided by r of s. Now take y of s as a common factor. So we need to find the transfer function, that is output by input, y of s as a output and r of s as a input, that is equal to g of s divided by 1 plus g of s into h of s. So just look at this block diagram initially. We have a intermediate variable as u of s. So for this u of s, we can write down the equation as r of s. First, initially y of s is equal to u of s into g of s. U of s is equal to r of s minus b of s. So and then make a product. Afterwards, that b of s can be written as, here we have output variable as y of s, that is the product of h of s. So just write on that, and then just shift it to the LHS part, and then take y of s as a common factor, because we need an output in terms of output by input, that is y by r. So that is equal to g divided by 1 plus gh. So if we have a block in this manner with a negative feedback, then directly that can be reduced into a single block. So in that single block, our output equation should be g divided by 1 plus gh. This is for a negative feedback. In the same way, let us the equation for positive feedback. So the same block diagram here, make it as a positive symbol. So let us the equation for this. Find the equation. So just here it's the alteration of initially it is R of S plus B of S. In here you have a plus, in here also we have a plus. So once we shifted to the LHS part, it is minus. So this is for a positive feedback. Write in the equation. ಬರ್ಕೊಂಡೈತಾ?
Yes, sir.
Yeah. So based on these concepts, so the first simple problem. So write in the question. Using the block diagram reduction techniques, find the overall transfer function find the overall transfer function y of s by r of s, y of s divided by r of s for the given block diagrams. For the given block diagrams. So the simple problem. So this is the first simple problem. So here we have a G1 and G2. Between we have a intermediate points as well as summation points. We need to find out the overall transfer function that indicates the final output should be y of s divided by r of s, and these whole multiple blocks are going to be reduced into the single block. So this is what we need. So this one we call it as a simplified block diagram reduction technique. We need to make that into a single block with a single output and input without any intermediate points. That we call it as a final overall transfer function. So here we have two summation points and we have two blocks. So now, so just look at the proper observation here. For this G1, we have a feedback element here. So we have a feedback element with a negative feedback. We don't have any block here. When we don't have any block, that indicates we have a signal as 1 here. So here the feedback element for a negative feedback. So what's the equation for negative feedback? So already we have solved that. What's the feedback for negative feedback? What's the equation? What's the
G of
equation for negative
y
feedback?
of s by r of s is equal to g of s divided by 1 plus g of s into h
So
of s.
g of s divided by 1 plus g of s into h of s. So this is the equation for negative feedback. So now in the place of g of s, we have a block variable as g1. So in the place of g of s, we have a block variable as g1. And then 1 plus g1 in the place of h of s. What is here? We have a signal as in the place of h of s. What is the signal here?
1.
We have a 1. So we don't have a variable as h. So that I'm going to just retain that as 1 plus g1. So now that whole block diagram, that feedback element block diagram can be reduced into g1 divided by 1 plus g1. We did write down in this manner. Afterwards, we have a g2. The last we have a output as y of s. And then write down the next feedback same as it is. Look at here, this whole block, this negative feedback, we have reduced into a single block. Afterwards, these two blocks are in series now. When two blocks are in series, what's the next operation you need to do? ಏನಿದೆ series ಅಲ್ಲಿ ಇದ್ರೆ ಏನ್ ಮಾಡಬೇಕು? First ಒಂದು ಏನಿದೆ ನೋಡಿ.
Into.
Multiplication.
Multiplication. So just perform the multiplication of these two blocks. That is g1 divided by 1 plus g1 into g2. So almost we come into the single block, but here we have a positive feedback element. Across feedback, we have a signal as 1 once again. So for a positive feedback, what's the output? What's the equation we need to write down? ಏನ್ ಬರೀಬೇಕು ಪಾಸಿಟಿವ್ ಫೀಡ್ಬ್ಯಾಕ್ ಗೆ ಈಕ್ವೇಷನ್ ಏನಿದೆ
g of s by
g of s by
1 minus
1 minus
g of s into h of s.
h of s. So we have equation as g of s divided by 1 minus g of s into h of s. Now in the place of g of s, we have a whole variable. So g1 into g2 divided by 1 plus g1 whole divided by 1 minus g1 indicates g1 g2 divided by 1 plus g1 g2 into h of s is 1. So this is the final reduction into a single block. So this is y of s and this one has r of s. We can able to simplify all this. So that is a reduced block diagram. We can able to write on simplified equation. So take LCM here and these two denominator get cancelled each other, so that g1 g2 whole divided by 1 plus g1 g2 minus g1 g2. So here we have only g1, it's not g2. So g1 g2 divided by 1 plus g1 minus g1 g2. So this is the final simplified block diagram. So take LCM and then simplify the equation. So that is the final simplified block. We have a multiple blocks. We have two blocks with the two summation points initially. So by using all those 8 techniques, we have reduced into a single block. So this is what we call it as a block diagram reduction techniques. ಯಾರಿಗೆ ಅರ್ಥ ಆಗಿಲ್ಲ ಕೇಳಿ ಇಲ್ಲಿ. ಯಾರಿಗಾದ್ರು ಅರ್ಥ ಆಗಿಲ್ವಾ? ಪ್ರದೀಪ್
ಸರ್.
ಅರ್ಥ ಆಯ್ತೇನಪ್ಪ?
ಎಸ್ ಸರ್.
ಪೂರ್ವಿಕಾ?
Yes, sir.
Yeah, with this I'm going to end the class today. We'll continue in the next class. So all of you just make entry of your presence in the chat box. So those who have entered at the previous, the earlier stages, so I will delete all those chat. So just make a entry when I'm going to suggest you people. So just now make a entry now. I'm deleting the previous chat. So just make a entry of presence now.